Students, in this class, we are going to learn how to integrate integral sine 200 1x times sine x raised to the power 199 times dx. Now, I'm going to be using this formula, which is sine of a positive b is equal to sine a cos b plus cos a sine b. Okay, so what do I do now? I'm going to rewrite sine 201x as sine of 200x positive x. So this is my a and this is my b. Using the above formula, this is going to be sine of 200x times cos x plus cos 200x times sine x. So using this expression into the question, I would now have, in place of sine 201x, I'm going to be using sine 200x times cos x positive cos 200x times sine x multiplied with sine x raised to the power 199 times dx. Now I'm going to bring this sine of 199 inside, so that would give me integral sine 200x times cos x times sine x raised to the power 199 positive cos 200x times sine x times sine x raised to the power 199 times dx. Now these two can be clubbed. Rewriting, we get sine 200x times cos x times sine x raised to the power 199 positive cos 200x times sine x raised to the power 199 times 1. I mean, you got a sine x raised to the power 1, right? So they would give you sine x raised to the power 200 times dx. So you got something like this. Now a very important observation you have to make is the pattern in which they are occurring. Now consider the differentiation of sine x raised to the power 200. Now if you were to differentiate this, you would get 200 times sine x raised to the power 200 negative 1, that's going to be 199, times differential of sine x would give you cos x. So if you were to rewrite this, it's going to be 200 times cos x times sine x raised to the power 199. Now you see here, you got cos x times sine x raised to the power 199. The only quantity that is missing is a presence of a constant 200, which we can handle it. Now if you were to consider the differentiation of sine 200x, okay, so that would give you cos 200x times differentiating 200x, that's going to be 200. Now if you were to see here, you got cos 200x, but you don't have a constant, so you can just handle that constant. So now what I'm going to be doing is, I'm going to be placing the constant in this fashion, multiplying the numerator and the denominator with 200. So it's going to be 200 times sine of 200x times cos x times sine x raised to the power 199, right, followed by a positive sign, 200 times cos of 200x times sine x raised to the power 200 times dx. So this is what we have got. Now you would have studied from differentiation d over dx of f of x times g of x is nothing but differentiating f of x times g of x. That's going to be my uv formula, right? So that's nothing but f of x times g dash of x positive g of x times f dash of x. Okay, so this is the law of uv, the product rule, right? Now clearly you have got this expression over here. Now I'm going to replace this expression with the product rule formula, which we have just studied. So on the right side, f of x times g dash of x positive g of x times f dash of x is nothing but differentiation of the two functions f of x times g of x. So this is going to be 1 over 200 integral. This entire thing is nothing but d over dx of f of x times g of x times dx. Okay, this is what we have got. So my problem is completed if I know what is f of x and what is g of x. Now the first part, you see here, differential of sine x raised to the power 200 gives me 200 times sine x raised to the power 199 times cos x. So you have what is present here as g dash of x. So this first quantity is going to be my f of x. So clearly I can write it here, f of x is going to be sine of 200x. So the second part will be my f dash of x. See, you can clearly see here, when you differentiate sine 200x, you get 200 times cos of 200x. So that is what is f dash of x here. So my f dash of x is present here. So this is going to be my g of x. And my g of x is going to be equal to, which is sine x raised to the power 200. Okay. So you can just substitute it there. D over dx of f of x sine 200x times g of x sine x raised to the power 200 times dx. Right, you can place it in parentheses. Of course, the differential and integral, they get cancelled out. So this is going to be equal to 1 over 200. The differentiation and the integration will get cancelled out, giving me sine 200x times sine x raised to the power 200. Positive constant c, which is important. So this completes the solution to this question.